Hello, everyone. I hope all of you are having a good evening. It's been long since I've come online on GMAT Club. I had um, I'd done a couple of webinars before for GMAT Club, and I think the webinars have done really well. So many of you all have seen my inequalities and absolute values videos. So GMAT Club reached out to me after a 6-year hiatus. I'm a personal tutor now, so I take one-to-one tutoring. So after 6 years, they reached out to me, and I couldn't, turn them down. So we have a lot of webinars planned out, right? Webinars where I deal with complete topics that you'll get to know. Maybe the first webinar is going to be next week. I think on 7th of July, you'll get some more details on that. I'm going to deal with the topic of algebra. So I have some topics in mind, and I'll be dealing with that. So I'm really thankful to GMAT Club to be very truthful, right? I think they reached out to tutors like me and other really good tutors on the verbal and quant front as well, so that we can reach out to a lot more people through this portal. All right. So before starting, diving into the questions, just giving you a heads up, I do things a little differently. I'm just not going to work the question, give you the answer, and move on. There's always going to be three parts of my discussion, right? Um, I'm going to show you how I tackle a question. I'm going to show you how you need to review a question. I wish, I had someone to tell me this when I was preparing, but it's something that I learned on my own. And third, we are going to go in depth in a discussion of a question. I'm going to speak about multiple processes of working a specific question. All right. So, just some ground rules. I normally will take care of multiple ways of working. So I request you, when I'm explaining a question, hold off with your doubts. Most probably, I might cater to them. If I still don't do, I will always give you a couple of minutes towards the end of the question to ask your doubts. All right. Thank you. I see a lot of nice comments on the chat window. So, without speaking too much, I don't like speaking too much. So, let's dive right in. Right. Let me share my screen and let's start. All right. Just before we start, I want quickly a quick confirmation if everybody is able to see my screen. Um, yes, in the chat window, and we can get into the discussion of this question. All right. Okay, so before I get into the questions, how were the set of 10 questions? Did you find it easy? Did you find it hard? Um, is there anything specific do you want me to cater to in addition to discussing the questions? If you can quickly type that as well in the chat window, I'll ensure that I cater to that during the session. If not, we can just stick to the discussion of the questions. Like I said, I'll always give you an add-on in terms of concepts as well. So, there will definitely be a takeaway for every question. Right. So anybody want to put in quickly, how are the 10 questions? Anything you want me to, cater to as well in addition to discussing this? Okay, the last ones, good ones. All right. Okay, so let's get started right away. So I think the first few questions are relatively easy. Now, this is something that I want to address from the get-go. Okay, and I want to address this because all of you all are preparing for the GMAT. This is exactly how I would want you to review questions. Okay, so I'm going to go in depth in the understanding of this question. I'm going to show you how I link concepts to working with it. And I will also show you what are the different ways of working. All right. Now, whenever I see a question that deals with inequalities and absolute values, I focus a lot on my question stem. The question stem, especially what constraints the question stem gives me, will always provide me some clue on what process can I employ to break down that question. So when I read a question, right, especially in an inequality and absolute value question, if you have a sign of a variable given to you, it's a huge, a very crucial piece of information. Why? Because when you're working with inequalities and absolute values with inequalities, when you have signs of variables given to you, you can manipulate the equations using multiplication and division. Not per se on this question, but if I work with any inequality and absolute value question, right, I always focus on the constraint. If they give me the sign of a constraint, in my mind, I would say it opens up the possibility for me to manipulate with that variable. Right? Remember, it opens up multiplication and division possibilities if you're working with inequalities. If you're working with an absolute value and you have the sign of a variable given to you, and that same variable is inside the absolute value, then it allows you to work with the definition of the absolute value in the most efficient way. So, the fastest way to work with this question would be to solve this algebraically using the definition of an absolute value. So, what is the definition of an absolute value? Normally, when I ask test takers what is the definition of an absolute value, everyone would tell me it's the distance that you travel from the origin on the number line. Now, if you ask me, right, that is one aspect of a definition. That is more of a visual definition of an absolute value. Many test takers don't focus on the algebraic definition of an absolute value. And I want you all to know this, right? The algebraic definition of an absolute value is given by the absolute value of x is plus x when x is greater than or equal to 0, and the absolute value of x is minus x when x is less than 0. This is the exact algebraic definition of the absolute value of x. It's a function. So when you have an absolute value of x, a function always will have a fixed definition. And when that function is used, you have to adhere to that definition, right? So if I need the absolute value of a here, I notice that I have a is less than 0. So if they give me information that x is less than 0 and they ask me about the absolute value of x, immediately I know that the absolute value of x should be minus x. So when a is less than 0 here, the absolute value of a is going to be minus a. The minus a in the second term I'm going to retain as it is. It's not inside the absolute value. And the absolute value of 2a when a is less than 0 will still be minus 2a. I'm just breaking it down using the definition. So it's minus a plus 2a, which then cancels out to give me a 0. So the correct answer choice here would be C. This is how I would look at it from an algebraic standpoint, right? I'm giving you the takeaways. This is exactly what I would do to review a question. It doesn't matter whether the question is an easy difficulty level or a medium or a hard difficulty level. Your focus, especially when you're preparing, is to try to review questions and look at multiple ways of attacking the question. So there's one takeaway, big takeaway here. Whenever you have the sign of a variable given to you in an inequality or an absolute value question, always remember, if it's an inequality based question, it opens up the possibility for you to manipulate with that variable. You can multiply and divide with that variable in your algebraic manipulations. If the sign of a variable is given to you in an absolute value question and you have the same variable inside the absolute value, it opens up that possibility for you to use the definition in a smart way. Right? For that, you need to know this algebraic definition. So that's the first point that I wanted to put forward here. Now, what is the second point? The second way of working this question, and this is for the test takers who, are a little hesitant about this topic. This topic falls under one of those tougher topic categories, right? Because many people don't have a very good understanding of an absolute value. And this is like a blanket rule on all algebra questions. Whenever you see an algebra based question with variables, and you see variables in your answer choices as well, you can always plug in values and work. That is always an option that is open to you. But the guideline to plugging in values would be ensure that you adhere to the constraint that is given. And my advice would be, and this is, I'm speaking from experience here because I worked with many questions and I've used the process of plugging in. Try to avoid working with -1, 0, and +1. The reason for that is because when you use values, you'll be forced to run through your answer choices. And when you're forced to run through your answer choices, right? And if you use -1, 0, +1, there can be a possibility that you may have two answer choices that give you the same answer. Right? So two simple rules: adhere to the constraints, and second, avoid -1, 0, +1. So what would I do here? Immediately I'll take a is equal to -2. I'm going to take this as, and the question is asking me to find the value of the absolute value of a minus the absolute value of 2a. So if I put a as -2, this will be the absolute value of -2 minus of -2 minus the absolute value of -4. So that's 2 plus 2 minus 4, which gives me 0. Now don't pick 0 as the answer. Run through your answer choices. You've put a as -2. So answer choice A is -2. Remember, I need 0 as my output. I eliminate A. B is -1. Clearly not. C is 0. I hold on to C. D is 1. Eliminate. E is -A. Remember, we have taken A as -2. So this would be 2. I eliminate. The answer would be 0. So these are the two ways that you have available to solve such a question. So remember two takeaways here. One, whenever you see the sign of a variable given to you in a question, use it to your advantage, whether it's an inequality or an absolute value question. And second, when you see a question that relates to algebra and all your answer choices are in the form of variables, ensure that you have the alternate approach available to you, right? You have the alternate approach of plugging in values and working. Ensure that you adhere to the constraints and avoid using -1, 0, and +1 as a part of plugging in. Got it? So, any doubts on this? I said I'll always give you a couple of minutes in the end. Any doubts, guys? Okay. See, why avoid -1, 0, +1, right? Why avoid -1, 0, +1? The reason for that is, I mean, I think this is not a good example for me. This question is not a good example for me to reiterate that point, but I would want you to try it out on other algebra-based questions, especially when you have variables in the answer choices. Put -1, 0, +1 and see what happens. And you'll see at some cases, you may have 2 or 3 answer choices giving you the same output. And if it gives you the same output, I can't pick one of the 3 answer choices, right? So I'll be forced to put in another value and work with it. Got it? Any other questions, guys, on this question? I see Pratik has asked the question, we only change sign of mod A, but not -A. Pratik, I don't need to change the sign of -A, right? The absolute value is the function that I am changing, right? The definition of the absolute value of A is +A when A is greater than or equal to 0, and -A when A is less than 0. So when A is less than 0, that constraint applies to the absolute value, right? So the minus a is as is, right? I will not change. Just because someone says a is negative does not mean I'm going to write it as minus a, right? All right. Can we move on to the next question, guys? Yes. Okay. So let's look at question 2. Again, a relatively simple one. You can go with pure algebra and work with it. You can work with absolute values in more of an intuitive process of working, right? So I'm going to give you both ways. I'll first give you the intuitive process of working, right? So when I see such a question, 2 into the absolute value of 2 minus x is equal to 5. So for people who are good with analytical skills, who want to spend time on the question and analyze and get to an answer, see, the analysis process, if done right, reduces the amount of algebra that you're going to have, right? So if you're going to analyze this, I know 2 into the absolute value of 2 minus x has to be 5. Now I'm going to ask myself, 2 into what quantity? 2 into what quantity is going to give me a 5? It's very clear, right? 2 into a 2.5 would give me a 5. So basically what I want is I want this absolute value of 2 minus x to give me a 2.5 for me to get to an output of 5. So if I want the absolute value of 2 minus x to give me an output of 2.5, then I know that whatever is inside the absolute value, 2 minus x, can be equal to a 2.5 on its own. Because if I put 2 minus x as 2.5, absolute value of 2.5 is still 2.5. That's 2 times 2.5, which is 5. Or 2 minus x can be equal to minus 2.5. Right? So that's the two possibilities that I have available. And now it's very easy for me to solve. So x here would be minus 0.5 and x here would be 4.5. And now the questions ask me, what is the sum of all possible values of x? These are the only two possible values of x. The sum is going to be 4. I would pick D. So this is more of an intuitive process of working that normally, ideally you should develop once you get accustomed to the topic, right? For example, if somebody tells me, right, absolute value of x minus 1 is equal to 1, I'm just taking an equation here. So the question that I'm going to ask myself in my head is, what value do I substitute here for x minus 1 that will give me an output of 1? So I know I can put a minus 1, the absolute value of minus 1 is 1. Or I can put the absolute value of 1, which is also 1, right? So I can immediately just look at it and say x minus 1 has to be 1 or x minus 1 has to be minus 1, right? And I can easily solve for x. That's more of an intuitive process of working, and it works really well, especially when you have a constant on the right-hand side like this. But you can't use this intuitive process of working if you have a variable on the right-hand side. If you have a variable on the right-hand side, you need to be doubly careful on what needs to be done, right? So let's erase this, and then let's look at the other way of working. For people who want to go conventional, want to split open the absolute value, like I said, simple rule, right? If you're going the route of splitting open the absolute value, and for those who split open the absolute value, took the two conditions, just my advice to them, whenever you choose to split open the absolute value, always do it based on its algebraic definition. Many people split open an absolute value directly. In this question, even if you split it up directly, you will still get to an answer. But in a more intricate question where maybe you have a variable on the right-hand side, splitting it open directly is not going to give you the answer unless you do an extra step. So what is the algebraic definition again? The absolute value of x is plus x when x is greater than or equal to 0, and minus x when x is less than 0. And one more thing, right, that I can take away from this question is this, that the absolute value of 2 minus x I can actually interchange the terms as well, is equal to the absolute value of x minus 2. Right? Absolutely okay for me to interchange the terms. I want you to understand this because everything is inside the absolute value. What I'm basically doing is I'm taking a minus 1 common and I'm saying x minus 2. And I'm taking the minus 1 outside the absolute value, which becomes 1, and I'm left with x minus 2. So feel free to interchange the terms inside the absolute value, right? Absolutely fine to do that. So if you were going with the definition, right? So I'm going to write this as 2 times the absolute value of x minus 2 is equal to 5. If you're going with the algebraic definition and you're splitting it open, my advice, split it open based on its exact definition. What do I mean by its exact algebraic definition? Take the conditions into consideration. Absolute value of x minus 2 will be x minus 2 when x minus 2 is greater than or equal to 0. So I will get 2 times x minus 2 is equal to 5. That is when x is greater than or equal to 2. And the absolute value of x minus 2 will be minus of x minus 2 when x minus 2 is less than 0. That is when x is less than 2. Whenever you choose to split open an absolute value, and I'm not only speaking about splitting open in this question, any time you choose to split open an absolute value, please do it based on the exact algebraic definition, taking these conditions into consideration. I'll tell you why it's important for taking the conditions into consideration. I'll take another example. I'll ask you all to solve, and then let's see how many different answers we get, right? So I've taken the conditions into consideration. Now I would solve for it. So 2x minus 4 is equal to 5. 2x is equal to 9. X is equal to 4.5. Now for this 4.5 to be a solution to my equation, it has to satisfy the condition that it's derived from. 4.5 is definitely greater than or equal to 2. That's a legitimate solution to that equation. Minus 2x plus 4 is equal to 5. So minus 2x is equal to 1. So x is equal to minus half, which is minus 0.5. X is equal to minus 0.5 is definitely less than 2, right? So it satisfies my condition. That is also a legitimate solution. These two are the solutions of my equation. The question is asking me for the sum. So 4.5 minus 0.5, which is 4. That would be my answer. Now, why am I giving you this? Again, like I said, right, I am not worried about just getting to an answer and moving on. I'm showing you how you can review a question, right? And in the process, I'm trying to give you some snippets of add-on pieces of information that you can take away and make a note when you're working with the absolute value questions. Now, the reason I'm very specific about splitting open an absolute value based on its definition is because of this. Let's say I give you this equation, okay? Solve for x. And I give you this equation, absolute value of x plus 1 is equal to 4x minus 3. So I want all of you all in the stream here to try solving this question in the way that you normally do it. Okay? Solve it in the way that you normally do it and tell me and type in the chat window what are the answers, what is the answer, or what are the answers that you would end up getting with this. Okay? I'm going to give all of you all a minute and then you all can type things in the answer. Okay, I'm already getting answers here. Pratik says 4 by 3, 5 by 2. Trisha, 4 by 3, 2 by 5. MVG, 3 by 4. 4 by 3, 2 by 5. MVG changes it to 4 by 3. All right. Natasha is also 4 by 3. All right. So I've got a good number of questions. Now this is for the people who gave me, 4 by 3 and 2 by 5 as an answer. This is your takeaway. Why am I saying that whenever you work with an absolute value, ensure that you split the absolute value based on its algebraic definition. I'm writing the algebraic definition here for your reference. It's the absolute value of x is plus x when x is greater than or equal to 0, or minus x when x is less than 0. This may not be the way I would solve it if you ask me. I mean, I'll hold on to the different ways of solving when we go into the actual webinar where I discuss absolute values. Yes, I'm going to discuss absolute values in depth in a good 2.5 hour webinar later. But I'm just going to speak about the algebraic definition here. I'm going to split this up. When you split it up, you have to split it open based on its algebraic definition. So the absolute value of x plus 1 will be x plus 1 when x plus 1 is greater than or equal to 0. That is when x is greater than or equal to minus 1. I'll get x plus 1 is equal to 4x minus 3. And the absolute value of x plus 1 is minus of x plus 1 when x plus 1 is less than 0. That is when x is less than minus 1. So these are the two conditions that I have to keep in mind when I'm solving for these. So when I solve for this, I'm going to get 3x is equal to 4. X is equal to 4 by 3. Now this 4 by 3 can only be a solution if it satisfies the condition that I've set up here. Is 4 by 3 greater than or equal to minus 1? It is. That's a legitimate solution to that equation. But here I get minus x minus 1 is equal to 4x minus 3. 5x is equal to 2. X is equal to 2 by 5. 2 by 5 is not less than minus 1. This is not a solution to the equation. This is what we refer to in terms of math, or what we refer to in math as extraneous roots. For those who got 2 by 5 as your answer, I want you all to take 2 by 5 and put it back into this equation and see if it satisfies the equation. So 2 by 5 plus 1 is equal to 4 times 2 by 5 minus 3. So that's the absolute value of 7 by 5 is equal to 8 by 5 minus 3. And if I simplify that, the absolute value of 7 by 5 is 7 by 5. 8 by 5 minus 3 is minus 7 by 5. So I can't have 7 by 5 to be equal to minus 7 by 5 in math, right? So this is not going to be a solution to that equation. So some of you all would have learned absolute values as I split open the absolute value, I get to my solutions, and then I take the values and I put it back into the equation and I check whether it satisfies the equation. Now you know why you put it back into the equation, right? Why? The reason you put it back into the equation is because when you split open the absolute value in the first place, you did not cater to these conditions based on its definition. So whenever you choose to split open an absolute value, you have to be very careful, especially when you have a variable on the right hand side. When you choose to split open an absolute value, always do it based on its exact algebraic definition. Got it? So that's a very, very important takeaway, right? Anybody with anything that they would want to ask me here? If not, we can move on to the next. All right. Let's go to the third. Now, let's take stock of what we've done so far, right? I said when we started the first question, spend time on understanding the constraints that the question gives you. If you have the sign of variables given to you, it's great. And the other thing that I notice here as well, look at the format of the question. Which of the following, which of the answer choices must be the greatest? And just by doing a vertical scan on the answer choices, I see they have all variables in the answer choices. And we also learned that when you have variables in the answer choices, you can also choose to put in values quickly that adheres to the condition that the question provides, and then run your way through the answer choices and pick the one that satisfies what the question is asking you. So two ways of working again. For the person who's a lot more intuitive, who likes breaking down the question, trying to analyze, this is what I would do from an analytical front. See, this is what I call a sandwiched inequality. Okay, it's just a term that I've coined, right? It's not actually, the term. I'm just calling it a sandwiched inequality because it's three inequalities that are put in one. Whenever I see a sandwiched inequality, right, whether it's a inequality based question or an absolute value question, I find it very, I find it much better for me to unpack the sandwiched inequalities. I always do this. So I would write this as 3x is less than 0 and 2y is less than 0 and 3x is less than 2y. Okay, this will help me a lot more. So if I divide both sides by 3, I know x is negative, I know y is negative, and I know 3x minus 2y is less than 0. This is what I would do. And another reason why I'm doing this is because I see 3x and 2y's in my answer choices as well, right? So if I want to go with the analytical process of working, I'm trying to, you know, analyze and trying to eliminate the answer choices which are very illogical. Second, I've got to this. I can't do anything beyond this, right? So let me glance at my 5 answer choices that I have. And they ask me which of the following must be the greatest. That's the most important. I look at 2y minus 3x. I have 3x minus 2y is less than 0. So obviously 2y minus 3x has to be greater than 0. So I know this is going to be some positive value. 3x minus 2y is going to be a negative value. So immediately I can knock off b because it's not a positive value, right? A would be greater than b at least. And if I look at answer choice E, right, that is 0. I'm getting a positive value for answer choice alpha. So obviously E cannot be a possibility as well. So I'm left with 3 possible answer choices, A, C, and D. And if I look at it a little closely, C is exactly the same as A, which is 2y minus 3x, which is another positive value. And obviously, right, think about it logically, I cannot pick an answer choice. If 2 answer choices are giving me exactly the same value, it's obvious that none of those can be a pick that I can choose and move on, right? So I would knock off these two. I'm left with D. That is the way I would look at it from an analytical front. But if I want to dive in a little more in depth, right, in the answer choices here, I've already eliminated B, I've already eliminated E. So what do I have now here? I have x is less than 0 and y is less than 0. And I also know that 3x minus 2y is less than 0. So think about it, right? I have both x and y as negative. Look at answer choice delta, right? Look at answer choice delta. Minus of 3x plus 2y. So this is a negative number. 3x is a negative value that's given to me. 2y is also a negative value which is given to me. And normally when you add two negative values, it will increase in terms of magnitude. Right? Two negative values, minus 2, minus 3 is minus 5. So the magnitude increases. And on top of that, you're taking a negative sign of that negative value. So obviously this, since it has a higher magnitude, will become positive because of the negative sign outside. It will have a much higher magnitude than answer choice alpha and answer choice Charlie. So I would pick delta as the answer. That is more of an intricate analytical way of breaking this down. But for people who want to just quickly solve this, if it is on test day, right, and I was quickly solving it, I just want to save time on this question. I would just quickly put some values and I would work with it. I know x is less than 0. I know y is less than 0. And I know 3x minus 2y should be less than 0. Right? I can quickly put in some values that satisfies this equation. I can put x is equal to a minus 1. And I can put y is equal to a minus 1 as well. Right? So remember, when I'm putting in values, I have to ensure that I satisfy the limitation. So x is minus 1, this would be a minus 3. And if I put y is minus 1, this will be minus 2 into minus 1, which will be a plus 2. Minus 3 plus 2 is still less than 0. And now I can navigate through my answer choices. So 2y would be a minus 2 plus 3, which would be a 1. 3x minus 2y will be a minus 3 plus 2, which will be a minus 1. Minus of 3x minus 2y will be minus of minus 1, which is plus 1. And minus of 3x plus 2y will be minus of 3x will be minus 3, minus 2, minus of minus 5 will be plus 5, and that's 0. So delta, I would pick that and I would move on. Got it? So again, what should be your takeaway on this question? Don't worry about the answer. This is a very simple question. What should be your takeaway? First takeaway, when I have a sandwiched inequality, it always helps me to break things down and unpack the sandwiched inequality. I can use these pieces of information to my advantage. And I used it to my advantage to try to reason it out. But the simplest way of working with this question, like I said before, if you have variables in your answer choices, you can just quickly put in values, solve, and get to an answer. Here I could use minus 1 and minus 1. It worked. It gave me values. But ideally, I would have tried to avoid using minus 1, 0, plus 1. I want you to try this, okay? Take your algebra questions from the official guide or from whatever resources you're using. And whenever you see an algebra question where you see variables in the answer choices, you have the opportunity of putting in values and working. When you put it and you see if you use minus 1, 0, plus 1, at some points, it may give you the same answer. Here we were lucky that it gave us unique possibilities for one to pick from, right? Why not C? I just proved it, Arpita. I just put values and I put, I put x is equal to minus 1, y is equal to minus 1. C gave me only a plus 1, right? But D gives me a plus 5, and I want the greatest possible value, right? So if I want the greatest possible value, that has to be delta, correct? No, Shweta, whatever you did is absolutely right. You can take 2y is equal to minus 2. That's what you're doing, right? You're doing what I've done. And you took 3x is equal to minus 3 and you ran your way through. That is also absolutely fine for you to work, okay? I think the bigger takeaway for you guys is, again, like I said, my entire intention is not to just focus on what is the shortest way to work. I'm going to give you the shortest way to work, but I'm going to give you all different possibilities to work. And I'm going to give you some takeaways that will be very, very crucial, especially when we go into the 9th and the 10th question. Got it? So any doubts here, guys? Relatively easy one again, not too problematic. I don't want to speak about how many people got it right, how many people got it wrong, because the intent with which I've come into this session is not to see whether this many percent of the people got it right or wrong, right? The intent of the session is more towards figuring out what are different ways of working. So let's go on to the next question. Okay. So it's more of a number property question that is, combined with inequalities. So when I see something like this, like I said, this is again a sandwiched inequality. I see powers of 10 on the left-hand side. What I want you to observe, right, is how I'm looking at a question. I'm not diving right in. I'm looking at the question. I'm staring at it for a while. I'm seeing what patterns I can notice. I'm asking myself, what is the best way I can work with it? And then I'm proceeding in the way of working. So I look at this, everything on the left-hand side and the right-hand side here of the inequality are powers of 10. That should give you a clue that it'll be better for me to represent this decimal also in terms of powers of 10. So I'm going to write that down first. Is less than, that's 1, 2, 3, 4, 5, 6. So that's 125 divided by 10 to the power of 6 is less than 10 to the power of n. This is what I would do as a setup first. I'll always want to represent things in powers of 10, right? And this is something I want you to also get accustomed to. It's not only that you do this when you work with decimals, you also do it when you work with integers. Say you get a number like this. Let me write it down again, 9919. If you get a number like this, right, and you're asked to break it down or you're asked to prime factorize a number, this is a very simple rule that you follow. Whenever you see a number where you have continuous strings of nines or continuous strings of zeros, whether it's a decimal, whether it's an integer, it's a very good indicator for you, especially on number property topics. It's a very good indicator for you to change that number into its power 10 format. Always represent the number in its power 10 format. So what would I do here? I would write this as 10,000 minus 81. So that will be 10 to the power of 4 minus 81. You see how it's designed, the number. They're giving you an opportunity to break it down. Minus 3 to the power of 4. And this is in the form of a square minus b square. So 10 square minus 3 square, 10 square plus 3 square. And then finally 10 minus 3, 10 plus 3 into 10 square plus 3 square. So this would be 7, 13, and a 109. You see, I could prime factorize it very quickly. So whenever you see numbers like this, right, it's an indication that you represent it as powers of 10. And another, clue that they give you is the left-hand side here and the right-hand side here are powers of 10 as well. Now, what would I do post this? I never try to keep a term in my denominator, especially when I have a number, right? And I know the sign. If I know the sign of a number, I can definitely multiply and divide by that number. If I don't know the sign, I cannot do it. Here I know 10 to the power of 6 is a positive value, so I can multiply throughout by 10 to the power of 6 without worrying about flipping of signs. So if I multiply 10 to the power of 6 into 10 to the power of minus 1 using the rules of exponents, it would be n minus 1 plus 6. That will give me an n minus 5 is less than 125 is less than 10 to the power of n into 10 to the power of 6. That will be 10 to the power of n plus 6. Right? Okay with this, all of you all? Now what would I do? I have a 125 here. And I have a 10 to the power of something here. And the questions ask me, what is the value of the integer n? They have given me n as an integer. They're asking me to solve for n. Now think about it, right? This number 10 to the power of n minus 5 should be less than 125. And the only power of 10, since n is an integer, that is less than 125 is 100. So that has to be 2. So 10 to the power of n minus 5, right, should be 10 square. So n minus 5 should be 2. Right? So what would be the answer here? Think about it, guys. What should n minus 5 be? 2. Have I made a mistake in the calculations? This is 10 to the power of 5 divided by 10 to the power of 6 into 10 to the power of minus 6. So I've multiplied by 10 to the power of 6 on both sides. I've got 10 to the power of n into 10 to the power of 6, that's n plus 6. And that's 10 to the power of n minus 1 plus 6, that's n plus 5, my bad. Right? So n plus 5 should be 2. So n has to be 2 minus 5, which is minus 3. That should be my answer. So this is another way you can work with it, right? You can use the powers of 10 to break things down. Always remember that when you see something like this, when you see numbers that have zeros in them, when you see numbers that have nines in them, that's an indicator to you to change it to a power 10 format and break it down. All right? Okay with this, everyone? Any doubts here? All right, let's go into the next question. Great. So one thing that I've noticed, especially in the focus edition, lots of questions on inequalities and absolute values are going to be in the guise of must be truths and could be truths, right? Somebody said in the previous question 10 is also less than 125. I wanted the previous question said very specifically what is the value of integer n, right? So if I take 10 as, which is also a possibility, what is there an answer choice that will satisfy that answer choice? No, right? So I'm not going to take that into consideration. Understood? All right, so like I said, right, when you have a must be and a could be kind of question, you're going to have a lot of must be's and could be questions on if you have the inequality in the absolute value topic. Again, going back to principles of what we put into the first question. I've been given that D is greater than 0. And I've been given a sandwiched inequality here. I can break it open if I want. Remember, they've given me the sign of D. So it opens up the possibility for me to manipulate using multiplication and division. And they ask me which of the following must be true. That means I have to pick something that is always true. The smartest way to work with this question is to work with it algebraically. Putting in values is going to be slightly problematic for one reason. If you're putting in values in an inequality and absolute value question as a first mode of attack, especially on questions like this, you have to test for multiple possibilities. You can't just test for one value and then reach a conclusion based on one value. You have to test for multiple possibilities. And what are the multiple possibilities you'll have to test for? Positive integers, positive fractions, negative integers. Only then will you be able to break the question down and get to an answer. So I have D as positive, and I have a sandwiched inequality. 0 is less than 1 minus C by D is less than 1. I'll split it up. 0 is less than 1 minus C by D, and 1 minus C by D is less than 1. I can add C by D on both sides. It's absolutely fine for me to add quantities or subtract quantities on both sides of an inequality. So I'm going to get C by D is less than 1 here. And let me subtract 1 on both sides. So I'm going to get minus C by D is less than 0. Immediately I see that I've got C by D is less than 1. I know 2 has to be true. I can eliminate the answer choices that don't have to. A goes. I can't eliminate anything else from this. I also have D is greater than 0. So I can get rid of this negative sign by multiplying throughout by negative. So C by D is greater than 0. And I know that D is positive. If D is by default positive, C also has to be positive for C by D to be greater than 0. So C is greater than 0 is also true. So 1 is also true. So I can knock off B. I can knock off D. So these are the two things I get just by simply unpacking the sandwiched inequality, using the information to my advantage algebraically. I get to these two possibilities. Now what I have to figure out now is the third. C square plus D square is greater than 1. Very difficult for me now to manipulate from what I have to get to C square plus D square. So quickly, if I was doing it on test day, I don't have a direct algebraical process to get to that. Immediately I will think, okay, what do I know? I know C is greater than 0. I know D is also greater than 0. This is given to me. If C is positive and D is positive, will C square plus D square always be greater than 1? No, not necessarily. What if they were fractions? If this was a half square plus half square is never going to give me a value that is greater than 1. So that gives me sufficient grounds to eliminate the third. So my answer has to be 1 and 2 only. Okay with this? All of y'all? Absolutely, Natasha. It's absolutely safe for you to unpack a sandwiched inequality, right? I mean, because think about it, no? How do you get a sandwiched inequality? 2 is less than x is less than 5, right? This is a sandwiched inequality, right? How is this inequality obtained? It says x is greater than 2 and x is less than 5. You can leave it as it is as well, and you can manipulate and simplify. I prefer to unpack it because I can get a lot more observations from the unpacked form than the packed form like this, right? So here it doesn't make sense for me to unpack it because I already have numbers on the left hand side and right hand side. Here it makes sense for me to unpack it, right? Because I took this as 0 is less than 1 minus C by D, and 1 minus C by D is less than 1, and then I manipulated with it. Remember, I'm just using the properties of inequalities. You can add or subtract quantities on both sides. You can only multiply and divide both sides with a positive or a negative value. If you multiply with a positive value, the inequality sign remains the same. If you multiply with a negative, the inequality sign flips. I cannot multiply or divide with a variable if I don't know the sign of that variable. Correct? On these kinds of questions, going with values is going to be a very dangerous proposition. Why? Because I have to test for multiple possibilities. In the event you want to go the route of putting in values, my advice, especially when you're working with inequalities and absolute values, the best way to put in values would be to draw a number line, put -1, 0, +1, and then check for extreme values in each of these regions. That's the problem, right? I have to ensure that it caters to all possibilities, and that's very difficult for me to do by picking values, because there'll always be an inkling of doubt. How do I know that for the value that I've picked within that range, it's always going to hold for all the other values as well? And that's the big risk that you take on an inequality and an absolute value question, right? By putting in values. So if you're going that route, if you're forced to go that route, my advice, put the number line, put -1, 0, +1, and check for extreme value. So I would check for 2, I would check for 100, I would check for a 0.1, I would check for a 0.9, I would check for a -0.1, -0.9, -2, -100, just to be on the safer side. That is why I would never go with this as a first mode of attack, right? But if they give me the sign, no, if they give me the sign of a variable and I want to go the route of plugging in, then I'm only constrained to these two sections. So I would only put in four values, one for extreme integers, the other one for extreme decimals, and work with it. But for such kinds of questions, putting in values is a very, very tedious and a dangerous proposition. So best way to work with such questions, I always feel, is try to break it down algebraically and work with it. Okay with this, all of y'all? Any specific question or any specific doubt on this question here? Yes, that's also a good way of looking at it, Pratik. Whenever you have a must be true question, the best way to work with a must be true question is to try to disprove. It's more like how you work with critical reasoning in verbal. I mean, for those who are preparing also on the verbal front, in critical reasoning, you at some points use a process of negation. Correct? You negate the answer choice and you check whether the negated answer choice satisfies the argument. If it satisfies the argument, you eliminate that answer choice. But if you negate the answer choice and it doesn't satisfy the argument, it breaks the argument, then that has to be true always. So that's what Pratik was saying, right? Whenever you have a must be true question, you should never try to prove these to be true. You should try to disprove. So what Pratik is saying is, if he's looking at C is greater than 0, instead of trying to prove C is greater than 0, he will see whether I can prove C is equal to 0 or C is less than 0. He'll negate it, right? And he'll see, if I take C is equal to 0 or C is less than 0, does my argument, does the information in the question hold? That is also a very nice process to work with a must be true question, going the route of disproving, right? But I always prefer working with algebra because algebra is more definitive in nature, but that's a very, very nice way to work. And this is how you can carry forward your learning in critical reasoning also on these kinds of questions, right? If don't ask me to explain negation here, maybe you can look up GMAT Ninja's videos on that, but it's similar to exactly what you do with negation, right, Pratik? I hope so. Pratik's comment was very valid. For option 3, are we using values anyway to solve it algebraically? Very difficult, right? I mean, for me to manipulate the conditions that I have to get a c square plus d square, I can't randomly square inequalities, right? It's a good question you're asking me. So this is something that you'll have to be very careful with when you're working with inequalities. You have to stay within the purview of certain guidelines. If I give you x is less than y, you randomly cannot square and say x is less than y square. Okay, that's not possible for you to do. So algebraically manipulating it like an equality is not done with an inequality. There are certain rules that you adhere to. You can only square both sides of an equation if you know both sides are positive, or if both sides are negative. If both sides are positive, you can square it but keep the inequality sign the same. If both sides are negative, you can square it but flip the inequality sign. The reason I didn't go with it, Avik, it's a good question you asked, is because I don't want to risk squaring. I don't want to risk, manipulating things without adhering to certain rules. I didn't have too many pieces of information. So immediately when I got C is greater than 0 and D is greater than 0, I had these two pieces of information. My mind went towards just analyzing this. If C is positive and D is positive, if I square two positive values, it need not give me a value that is greater than 1. Got it? All right. So let's move forward. Okay, now this is a good question. All right, so whenever you have exponents given in a question like this, exponents are tricky to work with. There are certain, everybody will know definitely what are the rules of exponents, right? Everybody will know a to the power of m into a to the power of n, a to the power of 0, a to the power of minus m. All the rules of exponents will be known by every test taker. But when you're working with exponents, right, there are certain guidelines that you always adhere to. Guidelines that will help you work with exponents in a much better way. These are a couple of guidelines. I won't give you all. I don't think we'll have time for that. These are guidelines for working with exponents. And I'm basing these guidelines on the rules of exponents themselves. The first, if you run through all the rules that you have for exponents, a to the power of m times a to the power of n, a to the power of m divided by a to the power of n, a to the power of m whole to the power of n, a to the power of 0, ab to the power of m, a to the power of minus m. In all of these exponents, right, there was absolutely no exponent rule for an addition of exponents or a subtraction of exponents. There was no rule for it. So what does that tell you to do? Whenever you're working with exponents, having an addition between exponents and subtraction between exponents is never going to help you out. So whenever you have addition and subtraction of terms, learn to convert it into a multiplication and division. And how can you do that? You can factor out common terms. You can identify a square minus b square patterns, right? So if I have something like 3 to the power of a plus 3 to the power of a minus 2, I will not leave it as it is. I will take 3 to the power of a minus 2 common, and I'll make it into a product. So this will be 3 square. Obviously, if I take 3 to the power of a minus 2 common, I'm asking myself, what should I multiply it with to get me 3 to the power of a? So obviously, the 2 has to cancel out. The minus 2 has to cancel out. So 3 square plus 1. So I can write this as 3 to the power of a minus 2 times 10. So you see, I've broken this down into a product. I always want to represent things in the form of products. If I have something like 3 to the power of a plus 3 to the power of a plus 3 to the power of a, I will take 3 to the power of a common, 1 plus 1 plus 1. That's 3 to the power of a times 3. And I can write this 3 to the power of a plus 1. Always try to convert addition and subtraction to multiplication and division. And that is exactly what I would do here as well. My first instinct when I look at what expression is given for x will be to say x is equal to 2 to the power of b minus. I'm going to first also, there's another second guideline. This is an obvious guideline. I'll just write it down anyway. When you're working with exponents, you always keep the bases the same or the powers the same. Okay, keeping the bases the same will help you equate exponents well. Keeping the powers the same help you compare exponents well. I'm not going into details of it, but I would keep the bases the same. So this would be 2 to the power of 2 cube into 3, 32 cube into 30, that's 2 to the power of 90. 16 is 2 to the power of 4, that's 2 to the power of 20. And then I would say x is equal to 2 to the power of b minus, I would take 2 to the power of 20 common, 2 to the power of 20 into 2 to the power of 70 plus 1. This is what I have, right? I would try to make things, this is 2 to the power of b. I would try to make things in terms of a product, right? And then when I look at this question, which of the following values of b yields the lowest value of the absolute value of x? So if I want the lowest value of the absolute value of x, I would want the lowest possible value for x. And if I want the lowest possible value of x, whatever I'm going to subtract from this quantity, I would want it to be equal to that quantity, because the lowest possible value for the absolute value of x would be 0. And for me to have that 0, I want them to be equal to each other. So I look at this and I say, okay, what can I do with this? I have 2 to the power of 20, 2 to the power of 70 plus 1, right? Now the plus 1 is just a very small add-on to 2 to the power of 70. So I can approximate this. So I can say x is equal to 2 to the power of b minus 2 to the power of 20 into 2 to the power of 70. I'm just approximating this. I know 2 to the power of 70 plus 1 is approximately 2 to the power of 70 itself, because 2 to the power of 70 is a very large value. I'm just adding 1 to it. So it's approximately 2 to the power of 70. I'm doing that because it then gives me the opportunity to club these, because the bases are the same, and take the power. So x is 2 to the power of b minus 2 to the power of 90. And I want the minimum lowest possible value of the absolute value of x. And the lowest possible value of an absolute value of x would be 0, right? And how can I get x to be 0 when the value of b takes 90? That is my answer. Okay with this? It's a tough question, slightly harder question. I don't know about the metrics on this question, so you'll have to tell me, right? C, Sirisha, you in the question 5, C is greater than 0 is a must solution, right? If I'll towards the end, if you can tell me, I'll go back to it and show you why it has to be true. Because if I get C by D to be less than C by D to be greater than 0, and D is positive, and C by D is greater than 0 is a definite information I know, then C also has to be positive, right? This is for Sirisha, who's still on question 5. So guys, when you work with exponents like this, always remember, set up the exponents so that they become conducive for you to work with the rules, right? Convert addition and subtraction to multiplication and division. You can do that by factoring out common terms using a square minus b square patterns, and always try to keep the bases the same and the powers the same. And then I focused on what the question was asking me. I focused on what is the lowest value of the absolute value of x. The lowest value of the absolute value of x has to be 0, right? Anything else, if I put for x, it will give me a positive value. So I asked myself, how can I make this 0 if these two terms have to be equal to each other? So I did an approximation at this point just to ensure that I can club the powers, and then got to my answer. Got it? All of y'all, any doubts on this? Okay with this? Okay with the add-ons here? What if you had to find the highest value, Pratik? Then, I can take b to be really large value, no? I will take the value of b to be a really large value, right? I mean, I can't put a number to it. No, it would be close to infinity there, isn't it? I would want to make the value of x to be really large, beyond 90, obviously. I would want to take a value really large, beyond 90, or really small, right? Really small decimal value, because both would give me positive values, right? So I can't definitively say what will be the greatest possible value of x, right? Okay with this, guys, everyone? See, don't be under the assumption that the GMAT is, will test you only on one concept at a time, right? It will test you on multiple things, right? A typical GMAT question will test you on more than one aspect. See, there's absolute values tested here, there's exponents tested here, there's an approximation tested here. So you have to be flexible towards working with multiple things, right? Okay. Okay, let's look at question 7. So again, like I said, I will try to, it's a must be true question. I think it was Pratik who also said that we can try to disprove, if I remember the name right. Right? You can disprove. You can think about negating and trying to disprove if you want to use numbers. But numbers, I said, is a very tricky proposition, especially when you don't have any limitations given. So it's always better to approach it algebraically. So b is not equal to 0. The reason they've given me that is because I have b in my denominator here. And obviously I can't have a denominator to be 0, but I'm going to work with this. 1 minus a by b is greater than 3. So I'm going to subtract 1 on both sides. So minus a by b is greater than 2. I will multiply throughout by a negative. So a by b should be less than minus 2. This is what I have. This is the definite information that I can glean from this. Basically, a by b has to be less than minus 2. It has to be a negative value, right? So now can any of y'all in the chat window say, if I have this observation that a by b is less than minus 2, what can I do in the first statement? Can I work with it? Or will I say it's true always? Can I eliminate it? What do you think the answer is going to be? Anybody who would want to analyze this? Guys, anything in the chat window? Obviously, right? I mean, here, what they're expecting me to do, what is the trap answer here? Is for me to multiply both sides by b, and then take a negative sign, minus a, and flip the sign is less than, and minus a is greater than 2b. This is what they're expecting me to do, but that would be completely wrong. Why? Because I cannot multiply and divide with the variable b because I don't know the sign of b. The value of b is unknown. The sign of b is unknown. So clearly, one is out. For a by b to be less than minus 2, for a division of terms to be negative, either b can be negative, a has to be positive, or a has to be positive, b has to be negative. So a cannot be always negative. So 2 also gets eliminated. So if I've eliminated 1 and 2, answer choice alpha goes, answer choice b goes, this goes, and this goes. I'm left with only c. But let's prove it, right? If a by b is less than minus 2, think about it, right? If I have a term, if x is less than minus 2, I can definitely cube it, right? X cube will be less than minus 8. Cubing never changes sign, right? I can definitely cube both sides. So if a by b is less than minus 2, a cube by b cube will be less than minus 8. Absolutely fine. Holds good. 3. Answer should be C. Got it? This is the best way for me to work with this question and break it down. Perfect. So you see what I did, right? I simplified the equation here. I got to this point, and then I try to reason things out from the possibilities, right? I don't know the sign of A. I don't know the sign of B. All I know is A by B is less than minus 2. I cannot say minus A is greater than 2B because that will involve me multiplying both sides by B and working, which I cannot do because I don't know the sign of B. I cannot say A is negative because A can be positive, B can be negative as well. But if A by B is less than minus 2, then a cube by b cube. If I cube a negative value, it would still be negative. So the third will hold. Make sense? All of you all? Okay, explain a is less than 0 again. See, what I've got here is this, right? I've got a by b is less than minus 2. Less than minus 2 means what? It's always going to be negative. If a division, if a by b has to always be negative, there are two possible scenarios for it. A can be positive, b can be negative, or a can be negative, b can be positive. They are asking me to figure out whether a is less than 0 is always true. A need not be less than 0 always, right? A can be less than 0. A can be less than 0, but a can also be greater than 0. So I can't definitively say that a is always less than 0. Why? Because a by b is negative, so a can also take a positive value if b takes a negative value. Okay, Shweta? Yes, one can be true. That would depend upon b being a positive, right? If they'd given you b is greater than 0, then one would have held, because then I can multiply. If a by b is less than minus 2, I can multiply both sides by b, so I'll get a is less than minus 2b, and then I can multiply throughout by a negative sign. Minus a is greater than 2b. If they had given me b is greater than 0, one would have also held. Got it? All right. Yes, if you change the question to a could be true, no, then the question becomes a 5-second pick, right? So if it's a could be true question, guys, then my process will not be to try to disprove anymore. It will just be try to prove. Can I get to a case where this is possible? Can I get to a case where this is possible or this is possible? So the question becomes way lesser in difficulty if I give you could be true. Okay. All right. Let's move on to the next. All right. So again, I've given you now, I've set up all the things that are required for us to tackle questions 8, 9, and 10. I think 8 also was relatively okay looking at the data that, of all your answers. 9 and 10 were the questions which were more trickier for most, and there was, multiple answers for both. So question 8, again, was a relatively easy one. I've already put in the format of working. I see something like this. Absolute value of x square minus x plus 1 is equal to 2x minus 1. Again, for people who are more intuitive in nature, y'all can analyze this equation just by looking at it. Ideally, as you get accustomed to working with this topic, you should also be able to develop analytical skills. And when you have an absolute value equal to something, you know that the output of an absolute value is always going to be 0 or positive. And if something which is 0 or positive has to be equal to 2x minus 1, I can say that 2x minus 1 is greater than or equal to 0. So x should be greater than or equal to half. Right? I can do this. I can analyze this and find out what limitation applies to this equation. It's a very intricate way of working. I'm not going to go into in depth why you would do this. This is called an analytical process of working with an absolute value. Maybe when we work with the absolute value topic, I'll go in depth in this. But this is one way you could have worked. You could have, analyzed this, got x is greater than or equal to half, quickly split it open, solved, and then cross-checked, cross-verified with the condition. But since our focus here is to understand what the definition of the absolute value is, the best way, and I think most of you all would have used this process of working, the best way is to split it open based on its definition. So the absolute value of x is plus x when x is greater than or equal to 0, and minus x when x is less than 0. Right? So think about it, right? I mean, if I'm going to split open this absolute value as is, what is the problem that I'm going to face? Anybody in the chat window? What is the problem do you think I'm going to face if I split open the absolute value as is? It becomes too problematic to take these conditions into consideration, right? Because I have a quadratic inside the absolute value, right? So this is where sometimes when you have an absolute value question, splitting open an absolute value may not be the best process to break things down. Analyzing the question may be better. For example, if I have something like this, right? If I have an equation, say like this, y into the absolute value of x is greater than, or let's say, let me change it here. X into the absolute value of y is greater than y square, right? So I give you something like this. It becomes very difficult for me when I have equations like this with multiple variables, or I have equations with multiple absolute values. 2x plus 3 is equal to absolute value of x plus 1, right? It becomes very difficult for me to split this open and take the conditions into consideration and then take all the different combinations of possibilities and work. Here as well, splitting this open means I have to take the conditions of y. I have an inequality also involved here. It's going to be too problematic for me to work. So what we do at some points when we work with absolute values, right? We always try to analyze an absolute value rather than attempt to split it open at the get-go. We try to analyze and see what observations we can get out of it. And what do? We use the absolute value term to our advantage. This entire absolute value term is always going to provide an output that is 0 or positive. In this case, the absolute value of y will always be positive. I can't have y to be 0, because if I have y to be 0, the left hand side and the right hand side both will be 0, and I can't have 0 greater than 0. So I'm using the absolute value term to my advantage, and I know that the entire term, the output is going to be positive. And I know this product x into the absolute value of y should be greater than y square, which is also a positive value. So if x into a positive value should be greater than another positive value, then this entire product should also be positive. So immediately I can analyze that, x has to be greater than 0. X has to be positive. And I can also analyze for this product to be greater than y square, the magnitude of x must be greater than the magnitude of y. The magnitude of x, this product xy, should give me a value in terms of magnitude greater than y square, which is y into y. So see what happens when you have absolute value terms with really ugly equations, multiple variables, multiple absolute values. It becomes very difficult for me to split it open and work with it. And that is where we go with the analysis process, right? What does the analysis process say? The analysis process says that when I'm working with an equation, suppose I have an absolute value associated with it. For example, y is equal to the absolute value of x. Use the absolute value term to your advantage. This entire term is always going to be 0 or positive. So since I know this entire term is going to be 0 or positive, I can comment upon the sign of y. So y has to be greater than or equal to 0. Right? And that's exactly what I'm doing here. I'm saying that 2x minus 1, this entire term is going to be 0 or positive. So 2x minus 1 should be greater than or equal to 0. So x has to be greater than or equal to half. This is the condition that governs this entire question. Right? Now what would we do after this? How would we work with x square minus x plus 1? Right? It's not a very easy equation for me to factorize. I can't factorize this directly. So whenever I have an equation like this which cannot be factorized, one option is to think of using the formula, which is very tedious. I've never come across a GMAT question that actually requires you to plug in the b square minus 4ac formula and work with it. But the other thing that you can do, right, when you have quadratic equations like this that cannot be factorized, you can always complete the squares. That is one good approach of working, especially when you complete the squares, right? You can understand and you can analyze equations much better. So can anyone tell me how would you complete the squares here? what would be the completion of squares here? How would you write this? Basically, the meaning of completion of squares is you're writing this as something squared plus or something or minus something. Only Strong says add 3 by 4. Strong's, why 3 by 4 specifically? How did you get to that value 3 by 4? One by 4 plus 3 by 4. Yes, you can write 1 as 1 by 4 or 3 by 4. Yes, I'm not going into the graphical approach in this, right? I mean, you'll need to have a very good, I understand what you're saying. I don't want to bring in coordinate geometry here at this point because not everyone will know how to plot a curve and how to plot absolute value on the graph. Okay, right? What you're saying is absolutely right. I understand what you're saying, but I don't think this is the place to discuss that because most test takers will not be able to make that link between algebra and coordinate geometry. Okay, the best way to complete the squares, guys, and you can take this as a formula, is take the middle term square. Okay, middle term square and divide it by 4 into the first term. Okay, if you want to quickly figure out what you need to add and you're not able to do it in your mind, take the middle term square. The middle term square is minus x square. So x square divided by 4 into the first term, which is 4x square, right? So you basically get 1 by 4, right? So that is what Stonks is saying to do, right? X square minus x. So basically you put it in this form. Let me erase this. So in what form do I want to represent this in? I want to represent this in a whole squared form. So what would I do to represent this in a whole squared form? I would write this as x minus half the whole square, or x minus 1 the whole square plus x. Absolutely fine for me to do that. Because one way to look at it, I can complete squares and write x minus half the whole square and work. Or I can also say that this is x plus 1, x minus 1 the whole square. What is x minus 1 the whole square? X square minus 2x plus 1. And if I want minus x, I'm going to add x to it. So I can say this is x minus 1 whole square plus x. And what can I say from this now? That x minus 1 whole square is a positive value. X I know is greater than half, so that is also positive. So I know that x square minus x plus 1 should also be greater than 0, right? It has to be a positive value that I get here as well. And now once I get x square minus x plus 1 to be a positive value, then I know this is going to open up as x square minus x plus 1 is equal to 2x minus 1. And if I simplify this, I'm going to get x square minus 3x plus 2 is equal to 0. And if I break it down, that's x minus 2 times x minus 1 is equal to 0. So x is equal to 2 or x is equal to 1. These would be my solutions. So the question is asking me what is the sum of all the possible values of x? That would be 2 plus 1, which is 3. Got it? See, guys, what I basically did is this, right? I mean, for people who wanted to know how to complete squares, put it in a whole square term, you can use middle term square divided by 4 into the first term. For people who want to, understand how to break this down efficiently, right? Why am I writing it down as x minus 1 whole square plus x? Because x square minus x plus 1 is not a quadratic equation that I can factorize. So I want to put it as something square plus something. So what did I do here? I know what is x minus 1 whole square. What is x minus 1 whole square? X square minus 2x, x square minus 2x plus 1. So if I want a minus x, right, what would I do? I would add x on both sides, right? So I can say that x minus 1 whole square plus x would give me x square minus x minus 1. And once I got x minus 1 whole square plus x, I know that x minus 1 whole square by default is going to be a positive value. X by default is going to be a positive value. So this entire term, x square minus x plus 1, is going to be positive. And since this entire term is going to be positive, I know x square minus x plus 1 is a positive value. So whatever comes out of the absolute value should be x square minus x plus 1 itself. That is equal to 2x minus 1. I got a quadratic that could be broken down and factorized. I solved for 2. I solved for x. I got 2 and 1. The answer was 3. Okay with this, all of you all? I'm not going to go into graphing it. I know what some of you all are saying. I don't want to go into trying to graph it out, please. Okay, because if I graph it out, then you'll need to know how to graph a quadratic. You'll need to know how to take the absolute values into consideration, right? You get a curve. So I'm not going to link it to coordinate geometry, though you can definitely do that here, right? Okay, let's quickly move on to the next. Absolutely fine for some who wrote x minus half the whole square plus 3 by 4. You can also keep this, and then you can say that x has to be greater than or equal to half, so this is going to be positive. 3 by 4 is also going to be positive, and this is equal to x square minus x plus 1, right? So if this is a positive value, because I know x is greater than or equal to half, this is going to be a positive value. This is going to be a positive value. So this entire thing will be positive. So either you can complete the squares and write this in this form, or if you are well versed with how to manipulate this, you could have written this as x minus 1 the whole square plus x as well. Both would give me the same thing. This is positive, this is positive, so this entire thing is positive. Got it? Okay, for people wondering why did I go into the sign of the absolute value, because what is the definition of the absolute value of x square minus x plus 1? The absolute value of x square minus x plus 1 will be x square minus x plus 1 when x square minus x plus 1 is greater than or equal to 0, or minus of x square minus x plus 1 when x square minus x plus 1 is less than 0. So by proving x square minus x plus 1 is x minus half the whole square plus 3 by 4, I know this is positive, this entire term is positive. Or for people who went this route of x minus 1 the whole square, I saw someone typed in the chat window about x minus 1 whole square, so I'm writing this as well. This is positive, so this entire thing is positive. So since x square plus x square minus x, I'm so sorry, x square minus x plus 1, since x square minus x plus 1 is positive, I will only take this definition of the absolute value, right? What is the definition here? X square minus x plus 1. That is why I split that as x square minus x plus 1 is equal to 2x minus 1, because I was able to prove that this entire term is going to be positive. So I only took this part of the definition, and then I got to my quadratic equation and I solved for it. Got it? So for those who did not get why did I square, why did I finish the squares, it was just to figure out what is the sign of x square minus x plus 1. I can split it up, but I'll have to take these conditions into consideration, Shweta. I can't just randomly split it up and work. I have to take these conditions into consideration and work if I do that. Okay, so this question I would want to discuss a little more in depth, especially 9 and 10, because I saw that most of you all got it wrong. It was a mixed bag of answers. Quickly type in the chat window how many of you all attempted this question by putting in values, right? First, I want to ask you how many of you all attempted this question putting in values. I think most of you all might have done that, because I see many of you all have given me A, some of you all have given me B. Okay. So this is for people who put in values. Okay. I see most of you all put in values. So remember what we discussed about putting in values in an inequality or an absolute value question. Don't randomly just put in a value and work. The best way to put in values is put -1, 0, +1 and test for extreme possibilities. The good thing is they've told you that x is positive here. So I don't need to worry about the negative portion of the number line. And they're asking me which of the following could be the correct ordering of 1 by x, 2 by x, and x square. I see many of y'all have picked B as an answer, and many of y'all had picked A also as an answer. Few of them have picked delta as well as an answer. For the people who have picked B as your answer, this is the mistake that most of you all would have done. And this is why I want to reiterate on how you need to use values on an inequality question. I said that if you're using values, don't pick one random value and test for it. Pick extreme values from these ranges. So 2 and 100 and a 0.1 and a 0.9. So let's run with this since most of you all have used values. Let's take the first. X square is less than 2x is less than 1 by x. So let's take 2. If I take 2, this will be 4. This will also be 4. Clearly doesn't work. So I know it's not going to work for the region that is positive integers. What about positive fractions? Let me take a 0.1. Most of you all would have taken a 0.5, I'm assuming, right? That's the normal number that everybody would take on this question. But like I said, use extremes. Let's take a 0.1. So if you take a 0.1, 0.1 whole square is 0.01. 2 into 0.1 is 0.2. And 1 divided by 0.1 is going to be 10. Clearly satisfies, right? So 0.1 satisfies the first equation. The question is which of the following could be. Could be. Could be means I just need one case to satisfy. 1 holds. So if 1 holds, A goes, C goes. And if C goes, right, to be truthful, even 3 goes because C is only 3 only, right? That would give you a clue that 3 should not work. But let's continue. So I've got 1. Now this is where most of you all have made your mistake in the second. You'll have just discarded it because you'll have just in the range of 0 to 1, you all would have only used a half and half wouldn't have worked out here. Always test for extremes. If I put a positive integer, it's not going to work because 2 square is not going to be less than 1 by 2. So I know integers don't work. But fractions, let me test for a 0.1 again. This will be 0.01 is less than 1 by 0.1, which is a 10, which is less than 0.2. That's not true, right? This is 10. I can't have 0.01. I can have 0.01 to be less than 10, but I can't have 10 to be less than 0.2. So I know it doesn't work with 0.1. And this is what many of you all use to eliminate the second. Remember, I need to prove it to be right. It's a could be question. So now I will check for the other extreme, 0.9. So 0.81 is less than 1 by 0.9, which is basically 10 by 9, is less than 2 into 0.9, which is 1.8. 0.81 is definitely less than 10 by 9, which is 1.11, is definitely less than 1 by 1.8. Holds good. So 1 and 2, right? So I can knock off B. I'm left with D and E. To be very truthful, I could have removed 3 as well because C3 only is done, but let's work with 3. So 2x is less than x square is less than 1 by x. Obviously, if I put a integer value, it's not going to satisfy. So it's all dependent on the fraction. So let me put a 0.1. So this will be 0.2 is less than 0.01. That's not going to be possible. So let me put a 0.9. 2 into 0.9 is 1.8. Is less than 0.81. That's also not possible. So it's not working for integers. Positive integers is not working for positive fractions as well. I can safely eliminate 3. My answer has to be 1 and 2. Now this is one way you could have worked. Okay. Most of y'all went this route. If you went this route, if you made a mistake by not considering extremes, this is your point. This is make it a point in your notebook that if I'm going the route of putting in values, I put in the number line -1, 0, +1, but I don't test for only one value in each of those ranges. I test for extreme possibilities. Got it? Now, how many of y'all went algebraic in this question and worked with it? How many of y'all tried to break the question down? Anybody? Did anybody attempt it that way? Nobody? Okay. I would have done this, but if you have to understand how to work with this algebraically, you have to understand how to work with something called quadratic inequalities. I'm going to use a quadratic inequality step here. If you don't understand it, because we have a lack of time, I would recommend you going through the inequalities video that is there on GMAT Club of mine. I explain exactly how to work with quadratics. But if I was working with this question, I would have noticed that x is positive, and I see that if x is positive, it gives me an opportunity to manipulate using that variable. And I see a sandwiched inequality, so I will break down the sandwiched inequalities. X square is less than 2x, and 2x is less than 1 by x. Since x is positive, I can manipulate with x. I can divide both sides by x here. Absolutely fine for me to do it. Since x is positive, I don't need to worry about the sign. So x is less than 2, and I can multiply both sides by x here. So 2x square is less than 1. So x square is less than half. And for people who know x square is less than half, how to work with it, if x square is less than a square, guys, I'm just going to write it here. The range of x will always be from -a to +a. Now, why is it like that? I would recommend you looking at the inequalities video, right? So if x square is less than half, the value of x will be between -1 by √2 and +1 by √2. But x is positive, right? So I cannot have the -1 by √2 possibility. So the range is capped between 0 and 1 by √2. So for the first statement, I have a range x is less than 2 and x is between 0 and 1 by √2. So basically, I need a value of x which is less than 2 and between 0 and 1 by √2. I can definitely have a value of x that satisfies both conditions here, right? Basically, this is what it will be. 2, and this is 0, and this is 1 by √2. So x is less than 2 and x is between 0 and 1 by √2. So any value between 0 and 1 by √2 will satisfy this first equation. So you see what I did? I'm trying to solve it algebraically. I can prove it algebraically. All I have to do is try to find out the value of x that satisfies that equation. Now if I go with the next, x square is less than 1 by x and 1 by x is less than 2x. X cube is less than 1 and 1 is less than 2x square. I can multiply throughout by x because x is positive. So if x cube is less than 1, x has to be less than 1, and 2x square is greater than 1. So x square is greater than half. So x should be greater than 1 by √2, or x should be less than -1 by √2. For those who don't know this, if x square is greater than a square, then x should be greater than a, or x should be less than -a. I can't consider the negative because x is positive. So x should be less than 1 and x should be greater than 1 by √2. So I need a value of x that is greater than 1 by √2 but less than 1. Greater than 1 by √2, less than 1. That's the range. So any value between 1 by √2 and 1 will satisfy the second equation. That is why 0.9 satisfied. But if I go with the last equation, you see what happens, right? You'll never get to a solution there. So again, I'm going to split it up, and x square is less than 1 by x. I'll divide both sides by x, so 2 is less than x, so x should be greater than 2. And I'll multiply both sides by x, so x cube should be less than 1. So x has to be less than 1. So I'm going to get x to be greater than 2 and x to be less than 1. I can't have a value of x to be greater than 2 and a value of x to be less than 1. So I can't have any solution here. Absolutely no values of x are going to satisfy both conditions simultaneously. So this gets ruled out. Only 1 and 2. This is more of an algebraic way of working with this question and exploring, right? But the best way would be to quickly put in values and work. But because you're dealing only with positives, but if you're dealing with positives, always take extreme possibilities and work with it. And finally, coming to the last question. Okay. So when I'm working with such a question, again, like I said, right, if x square is less than a square, the range will be between minus a and plus a. So again, when I see something like m square is less than 225, I would say the range of m would be between minus 15 and plus 50. If x could also be negative or 0, then I wouldn't be, doing the algebraical manipulation, HS, right? So in the previous question, if x was negative or 0, I wouldn't do the algebraical manipulation. I would just put in extreme possibilities even for the negative values, and I would check. Okay, that would not be a very nice GMAT question if they give you something like that. So guys, here again you see m square is less than 225. So I'm again using this to break it down. And they're giving me n minus m is equal to minus 10. This is also given to me. And they're asking me what is the positive difference between the smallest possible integer value of 3m plus 2n and the greatest possible integer value of 3m plus 2n. Okay. So I already have the range for m. They are asking me for 3m. So I can just multiply, throughout by 3 and say that 3m should be in between minus 45 and plus 45. And I also have n minus m is equal to minus 10. So it would make sense for me to try to find the range of n as well, right? Because I want n. So I have, if n minus m is minus 10, n plus 10 is equal to m. I can take this and I can substitute here since I have minus 15 is less than m is less than 15. I can replace the m as n plus 10 is less than 15. I can find the range of n. I can subtract 10 throughout. So that's minus 25 is less than n is less than 5. Right? So I know n has to be between minus 25 and plus 5. And the question is asking me about 2n. So I'll multiply by 2. Minus 50 is less than 2n is less than 10. So these are the two ranges I've got. Minus 50 is less than 2n is less than 10. Now the question is asking me, what is the smallest possible value of 3m plus 2n and the greatest possible value of 3m plus 2n? Whenever I have inequalities like this, where the signs are pointing in the same direction, right? I can always add. I can always add them. So minus 95 is less than 3m plus 2n is less than 55. So I've got a range for 3m plus 2n. And since I've got the range for 3m plus 2n, I can figure out what is the greatest possible integer value of 3m plus 2n. And I can get the smallest possible integer value also of 3m plus 2n. Right? So what is the greatest possible integer value of 3m plus 2n? 54. And what is the smallest possible integer value of 3m plus 2n? Minus 94. Yes? Any doubts here, guys? What I did here? Did you understand how I worked towards my question? How I found the value for 3m? How I found the value of 2n? And then I put them one below the other, and I can always add inequalities. For example, if I have a is less than b and b is less than c, I can always write a plus b is less than b plus c. Absolutely fine for me to do this. I can't subtract, I can't multiply, I can't divide, but I can always add inequalities. So I got the range for 3m plus 2n. It is between minus 95 and plus 55. But they're asking me what is the positive difference between the smallest possible integer value of 3m plus 2n. I know 3m plus 2n has to be greater than minus 95. So the smallest possible integer value will be minus 94. And the greatest possible integer value will be 54. 94 minus of 54 would be, I need the positive difference, but give me 148. That would be my answer. Got it? So what I want you to understand is when you work with multiple inequalities, yes, you can do that as well. If it's an integer, you can take it as minus 14 and plus 14. Pratik, that's absolutely fine for you to do as well because I'm working with integers, but I tend not to do that because I'm working with ranges here. But what you're saying is absolutely fine as well. Right? So if you're writing it that way, you're going to write it as minus 14 is less than or equal to m is less than or equal to 14. All right, Pratik? That's what you would do. Okay. You would put the equal to sign as well. I did not. I just left it as minus 15 to 15. And what I want you to hold on to, guys, here is that whenever you have sets of inequalities where the inequality signs are pointing in the same directions, you can always add the inequalities up. So a plus b is less than b plus c. So I added it up. I got to the range of 3m plus 2n. I took the greatest value, that would be 54 because I can't include the 55. I took the smallest value, that would be minus 94. And I got to the answer, 148. Okay. So this is what I had. I want you to keep in mind these takeaways. I would say maybe look through the video again, the recording of the video, to make a note of the takeaways if you've not done so far. I'll give all of you all 5 minutes just to quickly ask me some doubts, and then I think we're way over the time limit anyway, so we'll wrap it up at this point. Okay, any doubts, guys? I'm going to give you 5 minutes. You can ask me any doubt. I'm absolutely fine. Thanks, Ricardo, Natasha, Pratik. Good night. X to the power of 9, MVG Kannan says it's Kannan, just confirming, is it x to the power of minus 9? Minus x to the power of minus 7 is greater than 0? Yes, okay. So what I would do here, right, is I would write this as 1 by x to the power of 9 minus 1 by x to the power of 7. Now, one thing I always do is I follow something called the 3 golden rules, right? The 3 golden rules are: keep the right hand side 0, keep the left hand side as a product or a division of values, and always factor out even terms. You know why? Because even terms are always greater than 0. So I would pull out a 1 by x to the power of 6 common. Okay. And I would say this is 1 by x cube minus 1 by x is greater than 0. The advantage of pulling out a 1 by x to the power of 6 common is that would be positive, and I can only focus on the 1 by x cube minus 1 by x is greater than 0. Yes? Okay with this? Then I will pull out, I can factor this out further. Okay. Now I think you can go ahead and solve, right? So this is an x cube. So this would be 1 minus x square is greater than 0, right? So 1 minus x squared divided by x cube is greater than 0. So 1 minus x times 1 plus x. I can again take out an x square common. Divided by x is greater than 0. This is going to be positive. So now the question boils down to 1 minus x into 1 plus x divided by x is greater than 0. Right? I always keep the sign of the variable as x as positive, so I'll flip it. X minus 1 into x plus 1 divided by x is less than 0. So I will use the number line. I don't know if you know this process, but minus 1, 0, plus 1, plus minus, plus minus. This is less than 0. My solution should be on the negative portion of the number line. So x should be between 0 and 1, or x should be less than minus 1. That would be my solutions, Kannan. Okay. So if you understood what I've done, great. If not, then I would recommend for you to go through the inequalities video that is there. Okay. Great. All right, Kannan. So now it should match, right? X is less than minus 1, and 0 is less than x less than 1. So you can get things from there. Any other question, guys? All right. Great. It was great to be back. Thank you for so much. Thank you for all your comments first, and thank you to GMAT Club as well for bringing me on board. I hope to see you a lot going forward. Like I said, I will have a webinar that is algebra related in the month of July. And going forward, I'm going to speak about inequalities, absolute values, and I'm also going to take by, on because many people have demanded this. I'm also going to be taking up sessions on permutations, combinations, probability. All right. I'll see you guys. Good night. Take care. I'll see you next time.